Did you ever wonder if there is a development practice where your team can integrate code inside the shared repository and at the same time it can be checked for errors and bugs? This is John from Java Code Geeks, and today I'm going to show you how to write clean and efficient code in Java by using continuous integration. This video has been sponsored by DiffBlue. DiffBlue offers a free AI-powered unit test generation tool for Java developers. This AI, or in other words, DiffBlue's cover, has the ability to automatically write suites of unit tests for you in Java that would otherwise take days or weeks to write manually, and delivers human-readable code to increase your code coverage while ensuring you don't break anything along the way. Of course, DiffBlue's first AI-powered automated Java unit testing solution is now free, and it is available as a plugin of IntelliJ, the most popular IDE for enterprise Java to use with all Java code. Last but not least, each of you has the chance to get 3 free months of DiffBlue's Professional Edition, which offering test writing for packages, identification, and support by signing up using the link in the description below. Continuous integration is a development practice where each developer can integrate code inside a shared repository several times of day. Each integration can be verified through automated tests, which are not strictly part of continuous integration, but they are typically implied. Now, complementary to this video tutorial, you can find related articles and resources in the description below. Of course, you can visit Java Code Geeks to stay up to date with everything Java related. Just before we continue, if you guys like these guides and videos, take a minute to subscribe, like, and hit that notification bell, just so you know when the next video is up. So with no further ado, let's get started! More specifically, continuous integration is the practice of automating the integration of code changes from each member of the team into a single software project. It's a primal DevOps best practice that allows developers to frequently merge the code changes into a single repository where builds and tests are performed. One of the key benefits of integrating regularly is that you can detect the errors and bugs and locate them more easily because each change are typically small. Through the years, the continuous integration has become the best practice for software development, and it is guided by the set of key principles, which are the reverse control, build automation, and automated testing. Continuous delivery is an extension of continuous integration because it automatically deploys all code changes to tests and create a production environment after build stage. This means now that you have an automated release process that you can deploy your application whenever you want by clicking a button. With continuous delivery, you can decide to release daily, weekly, monthly. Continuous deployment goes one step further from continuous delivery. With this practice, every change that passes all stages of your production pipeline can be released to the customers. There is no human intervention, and the only thing that can stop the new change to be deployed to the production is a test that fails. Continuous deployment is an excellent way to accelerate the feedback loop with the customers and take pressure off the team. Continuous integration benefits are not limited to the engineering team, but also helps the whole organization. These benefits are, at first, it helps to fix the bugs faster. Frequent code pushes paired with automated tests deliver fewer bugs. It also makes the pinpointing issues easier. Secondly, it makes a strong code because by making small frequent commits, every developer can notice the new changes and the new problems that arise from them. Thirdly, it encourages rapid application development because the team can deliver to the key stakeholders faster and give the users new or change functionality more frequently. And last but not least, gives the ability to increase the efficiency and the productivity of the team, and also give you the ability to plan more frequent the updates and the tests. The most significant challenges on implementing an effective continuous integration are, at first, it is difficult to maintain continuous integration because the teams must build proper test suites and spending time writing test cases. This could slow them down and they will not complete their own tasks on time. Secondly, for larger development teams, they may see continuous integration error messages every day and start ignoring them altogether because they have their own tasks and concerns. And last but not least, some businesses will use traditional methodologies and may have some hard time on implementing continuous integration, or they have to retrain staff members, which would mean overhauling existing operations. As we said before, one of the abilities of continuous integration is to run tests and builds at the same time with other members of the team. This could be done with the help of continuous integration testing. Continuous integration testing is a testing that is focused and executed during the continuous integration process and orchestrated by continuous integration tools like Jenkins and Drone, which accounts for the build, packaging, and publishing of the artifacts. Of course, we expect a certain level of quality of the artifacts when they are being built during the release date. In some cases, when the artifact does not meet the minimum quality, the tests stop the progression. In the most cases, continuous integration testing focuses on the artifact before its deployment to the first integration environment. Continuous integration testing is used to test the quality of the artifacts through three stages: build, package, and publishing. Walking through the inception of continuous integration process, there are several types of continuous integration tests to run during the automated build. These are the unit testing, which cover the smallest possible component, unit, or functionality. They are cheap and fast tests to run because they don't require many dependencies or mockings. They should be done early to get out of the way. Secondly is the integration testing, which checks how well each unit from the previous stage work with other components, units, or functionalities. Furthermore, test the services, how well integrate with each other. And last but not least is user interface layer testing, which is an automated browser-based testing which checks the user flow. They are expensive to set up, slow to run, and it should be happen later in the pipeline. Interaction testing is defined as a type of testing where software modules integrated locally and tested as a group. A typical software project consists of these software modules, which are coded from different members of the team. The purpose of this level of testing is to expose defects from the interaction between them and check the communication amongst them. The integration testing has four types, which are top-down approach, bottom-up approach, sandwich approach, and the Big Bang approach. Now let's analyze the integration testing types. At first, let's talk about the top-down approach, which is a method that takes place from top to bottom and follows the control flow of the software system. The higher level modules are tested first and the lower level modules are tested and integrated in order to check the software functionality. Secondly is the bottom-up approach, in which the lower level modules are tested first. These tested modules are used to facilitate the testing of the higher level modules. Furthermore is the Big Bang approach, in which all the modules are integrated together at once and tested as a unit. And last but not least is the sandwich approach, in which higher level modules are tested at the same time with the lower level modules, and the lower level modules are integrated with the higher level modules and testing as a system. Now let's see a programming example. The first thing that we need to do is to add a new dependency for JUnit and the plugin to ensure that the class that we will write to the next steps will be executed only when we do the integration testing. So the next step is to create a new class with a name service object which has some attributes such as data, name, description, and status, and we declare the getters and the setters for each attribute. Furthermore, we create a new class with a name JUnitAsset equals example. In this class, we write three methods which theoretically pass the service object inside the processing group. The first method is the initiate data, which has a parameter which is the service object, and initialize the object. The second method is the process object, and we change the status to under process. And last but not least is the third and last method, which is the after processing, and we change the data variable and the status to complete. Now we need to mark our test cases, so we create a new interface in the test package with an integration test to categorize the test cases. After that, we create a new class with a name integration test sample test, and we use the category annotation in which we write the integration test class in order the program execute only this class. After that, we create two objects for the two classes that we set before, and we initialize the service object in the set data method. And last but not least, the before annotation, it is used because we want to execute the method below before running the test. Now we create two methods which are new test cases. The test assert equals false method checks if the object's new service object is different from the service object, and the next test assert equals false with message method if the service object is the same with the service object we created after the completion of the process. To execute the integration testing, we need to go to the life cycle of the project and click the verify button. As we can see at the output, the integration testing was completed and we have no failures or errors. The differences between unit testing and integration testing are: in unit testing, all the modules of the software are tested separately instead of integration testing in which all the modules are tested combined. Unit testing is a white box testing instead of integration testing, which is a black box testing. Unit testing is performed first of all testing processes instead of integration testing, which is performed after unit testing and before system testing. Detection of defects in integration testing is more difficult, and last but not least, unit testing is less costly. This testing approach offers a list of benefits which are: at first, the integration testing allows ensuring the appropriateness of the modules and their results. It also helps to detect the issues related to the interface between modules. Also, integration testing helps to stimulate the interaction between various modules. It covers multiple modules and provide a wider test coverage. It also helps to the overall testing efficiency of the software. And last but not least, it helps smoothen the transition between interfaces. I hope you enjoyed this video. If you did, be sure to smash the like button and subscribe to our channel. We have some really cool stuff coming up. Bye.